Hello everyone. Since from last few lectures we were discussing about mass spectrometry, this is once again from the same. As we know, the molecular ion undergoes fragmentation, a process in which free radicals or neutral molecules are lost from the molecular ion, and the general tendency for fragmentation is to give the most stable fragments possible. There are different modes of fragmentation like alpha cleavage, beta cleavage, retro-Diels-Alder reaction, inductive cleavage, elimination, and McLafferty rearrangement. Out of which, in today's lecture, I am going to explain McLafferty rearrangement and its mechanism with example. So, let us see in detail about McLafferty rearrangement. Rearrangement ions are fragments whose origin cannot be described by simple cleavage, but these are nothing but a result of intramolecular atomic rearrangement during fragmentation. Rearrangement involves the migration of hydrogen atoms in molecule that contain a heteroatom that may be nitrogen, oxygen, sulfur, like that. So it is the general structure in which the McLafferty rearrangement can be represented. So we can observe here the rearrangement involves the migration of hydrogen atoms in molecule that contain a heteroatom. Here the oxygen is a heteroatom present and the migration of hydrogen, it occurs from this gamma position. So this will be the intramolecular atomic rearrangement which occurs, and there is a formation of a number of fragments. So rearrangement ions are fragments whose origin cannot be described by simple cleavage, but these are nothing but the result of intramolecular atomic rearrangement during fragmentation. And it is nothing but the migration of hydrogen atoms in molecule that contain a heteroatom. The McLafferty rearrangement is a very common fragmentation reaction which is observed in mass spectrometry. This fragmentation was first described by Fred McLafferty in 1956. The McLafferty reaction takes place in such a molecule which having at least one gamma hydrogen and the functionality which can form radical cation. So the general structure of that molecule which undergo McLafferty rearrangement, it is here, it is shown in the first example. So it is the general structure of the molecule which can undergo McLafferty rearrangement where Z, that may be carbon, nitrogen or oxygen. The other examples when we observe, first that is alkene, then imine or carbonyl. These are also such a molecules which can undergo McLafferty rearrangement because these molecules can satisfy both conditions to undergo McLafferty rearrangement. That is, the first condition is nothing but that must contain at least one gamma hydrogen, and the second condition, the functionality which can form radical cation. So alkene, here we can observe this position is alpha, beta and gamma. So gamma carbon, and to which this gamma hydrogen is there. So there is a migration of a gamma hydrogen and an intramolecular rearrangement occur, and there is a formation of fragment. So McLafferty rearrangement is a very common fragmentation reaction that is observed in mass spectrometry, and the heteroatom that may be carbon, nitrogen or oxygen. So the first example alkene, that can satisfy both conditions, so it can undergo the McLafferty rearrangement. Second example, that is imine. Also, lone pair of electrons are present, double bond, that is pi electrons are also present, and presence of gamma hydrogen. So, also imine can satisfy these conditions to undergo McLafferty rearrangement. Next example, the carbonyl group. There is also number of pi bonds, pi electrons, and gamma hydrogen is present. Heteroatom is also there. So the McLafferty reaction, it occurs due to the presence of at least one gamma hydrogen and the functionality which can form the radical cation. So all these examples can satisfy both conditions to undergo McLafferty rearrangement. So all carbonyl compounds like acids, aldehydes, esters also satisfy this condition and can undergo McLafferty rearrangement. So to undergo McLafferty rearrangement, what should be the criteria? So first important condition or criteria to undergo McLafferty rearrangement is a molecule must possess an appropriately located heteroatom. So heteroatom, that may be oxygen, nitrogen, like that. The second condition is that a pi system, that means it may contain a double bond, that is having double bond or pi system. And the third important condition, that should have an abstractable hydrogen atom gamma to the carbonyl system. So gamma hydrogen, that should be present to undergo McLafferty rearrangement. So the criteria or molecule to undergo the McLafferty rearrangement is a double bond to carbon or nitrogen or oxygen, and the presence of hydrogen on gamma carbon with respect to the double bond. So that are the important conditions to undergo McLafferty rearrangement. A molecule that having a heteroatom, a pi system, and an abstractable hydrogen atom gamma to the carbonyl system. Only those molecules can undergo the McLafferty rearrangement. Now, what is the statement of McLafferty rearrangement? So, in the McLafferty rearrangement reaction, radical center in molecular ion abstract one hydrogen from the gamma position, during which pi bond is formed between the beta and gamma position, and the sigma bond between the alpha and beta position is broken and produces alkene and a new radical cation. So this will be the example, that is butanol, that can satisfy both conditions, that is having pi electrons, also a heteroatom, and the gamma hydrogen. So it can satisfy the condition to undergo McLafferty rearrangement. So the McLafferty rearrangement involves the cleavage of alpha beta bond followed by transfer of gamma hydrogen atom. This McLafferty rearrangement leads to the elimination of a neutral atom. In McLafferty rearrangement, the cleavage of bonds in molecular ion is due to the intramolecular atomic rearrangement, and this leads to the fragmentation whose origin cannot be described by simple cleavage of bonds. When the fragments are accompanied by bond formation as well as bond breaking, a rearrangement process is said to have occurred. Such a rearrangement involves the transfer of hydrogen from one part of the molecular ion to another via a preferably a six-member cyclic transition state. So this process is favored energetically because as many bonds are formed as are broken. This particular rearrangement and fragmentation is accompanied by the loss of neutral molecule. So here there is a loss of neutral molecule, that is alkene. In the McLafferty rearrangement, alkene is eliminated. So in this reaction, the molecular ion abstracts one gamma hydrogen, and there is a pi bond which is formed between the beta and the gamma position. Here the new bond is formed, and also the gamma position and the sigma bond between the alpha and beta position is broken, and it produces the alkene which is eliminated, and also a new radical cation. So ethylene, that is a eliminated, and the enol radical cation is formed. There is a formation of a six-member transition state and the transfer of gamma hydrogen. It involves the cleavage of alpha beta bond followed by transfer of gamma hydrogen atom. And in the McLafferty rearrangement, the elimination of neutral atom occurs. The McLafferty rearrangement can also be defined as beta cleavage with transfer of gamma hydrogen on radical cation during the six-membered transition state. As I have explained that it involves the cleavage of alpha beta bond followed by transfer of gamma hydrogen atom, and there is a formation of a six-membered transition state. This is also an example of 1,5 transfer reaction, as there is a transfer of hydrogen between first and fifth element. So this will be the same example, butanol. If we locate the position, here is the carbonyl group. So the first position alpha, then beta, then gamma. So it is the gamma carbon to which this hydrogen is attached. So it is called as a gamma hydrogen. And there is a transfer of hydrogen from gamma position to the heteroatom containing pi electrons. So if we consider here, that is the first position and it is the fifth position. So there is a transfer of hydrogen between first and fifth element. So this is an example of 1,5 transfer reaction. And there is a formation of six-member transition state due to the transfer of a gamma hydrogen on radical cation. So there is a formation of a radical cation or molecular ion, and then transfer of this gamma hydrogen to the radical cation to form the alkene, and one of the fragment that is called as enol radical cation. If we consider the resonating structure, so this will be stabilized and will get the formation of enol radical cation. So McLafferty rearrangement can also be defined as beta cleavage with transfer of a gamma hydrogen on radical cation during the six-member transition state. Now this is the mass spectrum of N-butanol. If we consider the mass spectrum, we know that on the x-axis there is a mass to charge ratio, and on the y-axis that is the relative abundance. As we know, the base peak arbitrarily having the relative abundance 100. So the largest and tallest peak, that is known as a base peak. Here we can see the molecular ion peak. In case of butanol, we get the molecular ion peak at mass to charge ratio 72.06, and the base peak is observed at 44.03. We know that base peak, that is the most abundant peak observed. So that will be the mass spectrum of N-butanol. So base peak can be observed at M2Z ratio 44.03 due to the formation of such a type of the ion, and the molecular ion peak which can be observed due to the formation of such a type of the structure at mass to charge ratio 72.06. So it is the interpretation of mass spectrum of N-butanol. Now let us see the mechanism in mass spectrometry related with the McLafferty rearrangement. The McLafferty rearrangement involves the cleavage of alpha beta bond followed by transfer of a gamma hydrogen atom, and there is an elimination of a neutral atom like alkene. Now the first step in the McLafferty rearrangement is that formation of a cation radical. The McLafferty rearrangement is intramolecular rearrangement, and the first step involved in this rearrangement is formation of radical cation. As we know, this molecule is bombarded with energetic electrons, and there is a formation of molecular ion also called as radical cation. Then the second step involved in the McLafferty rearrangement, the formation of six-membered transition state. So in McLafferty rearrangement, there is a migration of a gamma hydrogen towards oxygen of carbonyl group, and during this rearrangement, odd electrons ions are formed, and there is a formation of six-membered transition state. As we know, to undergo McLafferty rearrangement, it should have pi electrons, it should have a heteroatom, and also it should have gamma hydrogen. Only those molecules can undergo McLafferty rearrangement. So the second important step involved in the McLafferty rearrangement is formation of six-membered transition state. As we know, the radical cation is formed, then there is a migration of a gamma hydrogen towards the heteroatom, and there is a formation of a new bond. Also, there is a breaking of another bond. Here, the transition state, six-member transition state is formed. And next to that, the formation of a fragment and elimination of alkene, ethylene, and formation of this cation, enol radical cation. So McLafferty rearrangement involves these two important steps. First step, that is a formation of a radical cation. When a sample molecule is bombarded with energetic electrons, there is a formation of a molecular ion or radical cation. Further, the transfer of a gamma hydrogen towards heteroatom occurs, and there is a formation of six-membered transition state. And next to that, elimination of alkene. During rearrangement, odd electron ions are also formed, and formation of enol radical cation. We can summarize this mechanism. In McLafferty rearrangement, there is abstraction of gamma hydrogen followed by cleavage of beta bond to form two fragments, that is first one is olefin, alkene, neutral olefin, and the second fragment, that is enol. So enol radical cation is formed, and one molecule, that is a neutral molecule, is also formed during the McLafferty rearrangement. Cleavage of beta bond and abstraction of gamma hydrogen. We can observe here, this will be the gamma hydrogen, as we label here alpha, beta and gamma carbon. So to this gamma carbon, the hydrogen atom is present. Transfer of this gamma hydrogen occurs and also it is followed by beta cleavage to form two fragments. One is enol radical cation and second one is neutral species, that is neutral olefin. So very simple mechanism involved in the McLafferty rearrangement. Now let us see few examples of McLafferty rearrangement. So first of all, McLafferty rearrangement for carbonyl compounds. So this will be the example. Here what happens? If we locate the position, this will be the carbonyl group. It is alpha, beta and gamma. As we know, only those molecules which satisfy the conditions can undergo McLafferty rearrangement. So first important condition, having pi electrons. It should have abstractable gamma hydrogen and also preferably located heteroatom. So all these conditions are present in the given example. So the McLafferty rearrangement is possible for this example. So alpha, beta and gamma hydrogen. So this gamma hydrogen can show the transfer of towards the heteroatom and there is a formation of a 6-member transition state, further formation of fragment. Here molecular ion can show the peak at mass to charge ratio 86 and after that the formation of such a type of the radical cation, enol radical cation, can show the peak at mass to charge ratio 44. So here the H transfer from gamma hydrogen, gamma carbon results in loss of a neutral alkene. So the neutral alkene is eliminated during the fragmentation. Now again the different carbonyl compounds like aldehydes, ketones, carboxylic acid, ester, which having the gamma hydrogen can undergo McLafferty rearrangement. So the first example, McLafferty rearrangement of ketone. Molecular ion can show the peak at mass to charge ratio 128. Here also the transfer of gamma hydrogen occurs. There is a formation of a 6-member transition state. Further formation of a radical enol cation shows the peak at mass to charge ratio 58 and the alkene, the neutral species can be eliminated. So 1-pentene is eliminated as a neutral molecule and the peak is observed only due to the presence of radical enol cation at mass to charge ratio 58. The another example, the McLafferty rearrangement which is observed in carboxylic acid. Again, the condition is suitable to undergo McLafferty rearrangement as there is a presence of a heteroatom and also the gamma hydrogen. The transfer of a gamma hydrogen occurs towards a heteroatom, formation of a 6-member transition state, further the cleavage of a beta bond, alpha beta bond followed by the transfer of a gamma hydrogen leads to the formation of enol radical cation and the alkene can be eliminated as a neutral species. So we get the formation of a peak at mass to charge ratio of 60 due to this type of the fragment, that is enol radical cation. So first peak can be observed at 88 mass to charge ratio. Molecular ion peak is observed at 88 and the radical enol cation can show the peak at mass to charge ratio 60. As we know, in the mass spectrometer, only the positive species or the radical cation can be detected, whereas the neutral species cannot be detected. So, this fragment can be eliminated during the fragmentation. Again, the McLafferty rearrangement for particular example of carbonyl compound 2-octanone ketone. So let us see this particular example. Here also the gamma hydrogen is present. As we know, this will be the alpha position, it is the beta, and it is the gamma position. The molecular ion peak due to the fragment or the mass to charge ratio can be observed at 128. Then further there is a loss of this fragment C6H13, and there is a formation of a new species which can show the peak at mass to charge ratio 43. Again, if we consider this cleavage, we get the peak at M to Z ratio 43. But if we consider the McLafferty rearrangement, that is the transfer of this gamma hydrogen, then the fragment, that is the formation of enol radical cation, can show peak at mass to charge ratio 58. So in case of 2-octanone, there may be the two ways of fragmentation. First one, that is the loss of C6H13 radical, and the second way, that is loss of pentene via McLafferty rearrangement. As I have explained in detail about McLafferty rearrangement, so there is the transfer of a gamma hydrogen, and that is the intramolecular rearrangement to form the enol radical cation. So if you observe the peak at mass to charge ratio 58, that indicates there is a formation of enol radical cation via McLafferty rearrangement. And we know that in McLafferty rearrangement, neutral alkene can be eliminated, and the product, that is nothing but a radical cation, enol radical cation, which can be observed in the mass spectrum also. So let us see the mass spectrum of 2-octanone. So it is the mass spectrum of 2-octanone. So via alpha cleavage, the peak is observed at mass to charge ratio 43 due to the formation of such a cation, and via McLafferty rearrangement, in case of 2-octanone, the peak is observed at mass to charge ratio 58. So we can say this peak is also known as a base peak. It is due to the formation of enol radical cation via McLafferty rearrangement. Whereas if we consider the molecular ion peak, that is observed here, and also via the alpha cleavage, the another fragment is observed at the mass to charge ratio 113. So this will be the important mass spectrum of 2-octanone. If you observe via alpha cleavage, the peak is observed at mass to charge ratio 43 and again at 113. If we consider the McLafferty rearrangement, there is the formation of a peak at mass to charge ratio 58 due to this radical enol cation. Now let us see the another example, the McLafferty rearrangement in case of alkyl benzenes. Here also the molecular ion peak is observed at 134, and if we consider the condition, that is having gamma hydrogen, so that gamma hydrogen can be migrated to form the 6-member transition state, and there is a formation of a new fragment. So first of all, there is a loss of this CH3 CH double bond CH2, and we get the formation of this type of the cation, radical cation, at mass to charge ratio 92. Also, if we consider the removal of this type of the radical, propyl radical, we get the another type of the fragment, and the peak observed that may be at mass to charge ratio 91 due to the formation of tropylium ion, like that. So that will be observed in case of alkyl benzenes. Again, let us see a few examples of McLafferty rearrangement. So first example, that is 2-hexanone. Pi electrons are present. A heteroatom is also there. Gamma hydrogen is present. So such a molecule can undergo McLafferty rearrangement. So 2-hexanone undergo the McLafferty rearrangement. First of all, there is a formation of a radical cation. Then next step, the formation of 6-member transition state, and further the alkene neutral space is eliminated and formation of enol radical cation, which can be detected in mass spectrometer. So here the acetone enol radical cation is formed, which can be detected. That peak can be observed in the mass spectrum due to the acetone enol radical cation formation. Second example, hexanoic acid. Here also both conditions can be satisfied, so it can also undergo the McLafferty rearrangement. Elimination of alkene, neutral species 1-butene, and formation of enol radical cation, which can be detected, and also the peak is observed due to the formation of acetic acid enol radical cation. Another example, methyl hexanoate, that show the formation of methyl hexanoate enol radical cation and 1-butene eliminated in the McLafferty rearrangement. So saturated alcohols, saturated amines cannot undergo McLafferty rearrangement because of lack of pi electrons, but those molecules which have pi electrons, n electrons, gamma hydrogen, and a heteroatom can undergo McLafferty rearrangement. So in detail we have studied different examples of McLafferty rearrangement. So in today's lecture, we have studied the McLafferty rearrangement, its mechanism, and different examples. In next lecture, we will discuss about rule of 13 and also the examples of rule of 13. Thank you.